Hi. So we will discuss motion of charged particle in a uniform magnetic field. So let us just assume that there is a charge Q, and this charge Q has, let's say, has velocity v and is under the influence of magnetic field B. So in such cases, it will be under the influence of two forces. So that would be centripetal force and magnetic force. So equally, this charge will be under the influence of magnetic force as well as the centripetal force, and it will kind of perform the circular motion. Basically, if I want to write an equation for magnetic force, then I can write it as okay. So first of all, I'll just write down, let's say, magnetic force. Um, so magnetic force is Fn. So Fn is equals to F is equals to Q into V cross B. So it is a cross product basically. So here in such case, its velocity is going to be perpendicular to the magnetic field. So here V is perpendicular to magnetic field. But before that, we should write the equation in this format. That is Fm is equals to QVB sine theta. So friends, please understand that if it is a cross product, like if it is V cross B, so we can simplify it as VB sine theta. Okay, so, but, but uh, it's like theta is equals to 90 as V is perpendicular to B. So that is F is equals to QVB sine 90. So that's why that would be F is equals to QVB. So let's call this as equation 1. So this is actually Fm, but there exists, uh, but okay, I write in better handwriting, but but there also exists the centripetal force, so which is represented as, so yeah, friends, I'll be writing centripetal force as Fc is equals to mv square upon r, and I will call it as equation 2, and then we will be equating mm, equation 1, 1 and equation 2. So I'll be writing Fc is equals to Fm. So therefore it is like mv squared upon r is equals to qvb. So that would be mv upon r is equals to qb. So here I can get the radius. So mv upon qb is equals to r. So I can call this to be equation 3. So this is the radius of the path that the charge travels while being under the influence of centripetal force. Now velocity. Now velocity of the charge can be represented as, so we can represent velocity as v is equals to displacement upon time. So we can write time is equals to displacement upon So since displacement as in, the distance traveled here would be 2 pi r, as it is around the circumference of the circle. So that is why t is equals to 2 pi by v into r. Okay, so let us call this to be equation 4. So I'll just write down here, substitute, substitute equation 4, sorry, equation 3 in equation 4. All right. So that would give me t is equals to, therefore, therefore t is equals to it is 2 pi by v into mv square upon v square upon, अच्छा, ये equation था. This equation is what we are supposed to substitute. So I'll be substituting it as mv upon qb. So mv will be mv upon qb. So we'll be cancelling v. So therefore t is going to be 2 pi m upon qb. So this is the time taken. So now if I want frequency, okay, frequency can be written as, so how do we write frequency? It's going to be mu is equals to 1 upon t, which is equal to 1 upon 2 pi m upon qb, which is equal to qb upon 2 pi. So I can also write it as, therefore mu is equals to 2 pi, mu is equals to, sorry, not 2 pi, but qb upon qb upon 2 pi. This is how I can write it. So this is basically the frequency. This is basically the expression of cyclotron frequency. The amount equation represents the cyclotron frequency. I hope this video was helpful to you, and I hope it helped you to derive cyclotron frequency with very clear steps. So I'll see you with the next video. Bye.